Hello, you're welcome to Wiseman's Online Mathematics. We have on the board Matrix Algebra. If you have not subscribed to my channel, why not subscribe? Hit the subscribe button there for more on Matrix Algebra. Now, I have Matrix Algebra. So in this video, I'll be defining matrix, the order of matrix, and also the types of matrix. Now, let's start. Now, what is a matrix? A matrix, the plural form of matrix is what we call matrices. Matrices is the plural form for what? Matrix. A matrix is a set of numbers or elements, as the case may be. It's a set of what? Numbers or what? Elements arranged in a rectangular pattern. Like what we have here. These are set of numbers, or we call them elements. It could be a boy, girl, as the case may be. Now, these are set of numbers arranged in rectangular manner, rectangular pattern. Now, what are the order? What do we call order? Order is how we name metrics. How do we name metrics? The order of a metric gives its size in terms of rows and columns. This is very important. In terms of what? Rows and columns. Now, for the rows, this is the horizontal direction, and for the column, this is the vertical direction. Now, what do we call the horizontal? The horizontal goes like this, horizontal, and then the vertical goes like this. So this is what we call the vertical direction. Now, they say the number of rows is always written first. Now, how do you name matrix? You name from the row before the column. You count the number of rows, and then before you count the number of columns. Like this. If I'm to give the order of this matrix, it's 1, 2. You have 2 rows. How many columns? 1, 2, 3. 3 columns. So this is 2 by 3 matrix. This is what we call 2 by 3 matrix. What about this? We have 1, 2. 2 rows, 1 column. So 1 column. So this is 2 by 1 matrix. Now, how many rows here? 1 row. How many columns? 1, 2, 3. So 1 by 3. Now, what about this? What's the order? This is 1, 2. And how many columns? 1, 2. So this is how you name matrix. So this is how the order of matrix is. So order of matrix gives its size in terms of what? Rows and columns. So you name it according to rows. This is 2 rows, 2 rows, 3 columns, 2 rows, 1 column, 1 row, 3 columns, 2 rows, 2 columns. So the next part here, the next thing I want to discuss is what we call the types of matrix. On the types of matrix that we have the null matrix, we have the row matrix. Now, if we talk about the null matrix, it has all elements to be what? 0. That is to say that all its elements is what? 0. They are all what? 0. That's what we call null matrix. That is all its elements, they are all what? 0. Then when we talk about row matrix has only one row. It may have series of columns, but any matrix that has just one row is called a row matrix. That's in this case you have just a single row, and then although we have 4 columns here, irrespective of the number of columns, so long it has one row, it's called a row matrix. Then we have what we call the column matrix. Column matrix has only one column. That is what we have here, just one column, irrespective of the number of rows, just one column. We have the square matrix. Square matrix, that is the number of rows and columns are what? Equal. That is 1 row, 2 rows. So we have 2 rows and 2 columns. So in a case like this, we have what we call the square matrix. So we have the diagonal matrix. It is a square matrix. So take cognizance of this. It is a what? A square matrix. As what we have in the previous page, I said a square matrix is where a matrix that has equal row with the what? Column. So it is a square matrix where all the elements are 0 except for those in the diagonal, and it is from the top left to the bottom right corner. What am I saying? Now check this diagonal. A square matrix is where you have this diagonal from the top left corner. You can pick a diagonal like this. This is also a diagonal. This is also a diagonal. But we're picking the one from here. That is from the top left corner of this. So any matrix where you have numbers or elements that are more than 0 and it happens to be on the diagonal is called diagonal matrix, where the rest of the elements are what? 0, except the numbers in the diagonals, right? Now we have what we call the scalar matrix. It's a diagonal matrix. So scalar is a what? Diagonal matrix. That is equal row with equal row and equal column, where all the diagonal elements are equal. Where all what? The diagonal elements are equal, like this. So we have it like this. So we have this is to happen. This is what? A scalar matrix. In this case, it's not a scalar matrix because the diagonal do not have equal elements. But here we have equal elements. So we call it a scalar matrix. Another matrix again we have is what we call the unit matrix. So another name for unit matrix is what we call the identity matrix. It is a scalar matrix. So I think in F I said the scalar matrix is a matrix where you have the diagonals to be what? Equal. Now, but if these diagonal elements are all one, you call it a unit matrix or identity. So, but generally they are all what? Scalar matrix. So scalar matrix is where you have this diagonal to be what? Equal. So when you have that diagonal to be what? Equal, it means it's a what? Scalar matrix. And you know this is a diagonal matrix also, right? It's a diagonal matrix. So a scalar matrix is where you have this line to be what? Equal. But when it is 1, it has a special name. When the diagonal elements, they are all 1. If they are 1, it has a special name called what? The unit or identity matrix. Then we have the upper triangular matrix. Upper triangular matrix is a square matrix. So you must know that it is a what? A square matrix. When all the elements below the left hand side, that is like this. So this is what we call the upper triangular. We have all the elements greater than 1 to be upper. This is the upper region, like this. You get it, right? So this is the upper region. This is what we call the upper triangular matrix. So below it, you have what? 0. So below this kind of matrix, you have what we call what? 0. This is what we call the upper triangular matrix. And then the next one we have again is the lower triangular matrix. And the lower triangular matrix is a square matrix also, just like the upper triangular matrix, whose elements in the diagonal, that is the diagonal below, we have the diagonal, the diagonals above, we have them to be what? 0. So we have elements like this. So this is the diagonal. So all the elements are greater than what? 0. But the diagonals above will have what we call 0. They are filled up with what? 0. So any matrix where all the elements above the left to right hand diagonal, that is from the left going towards the right diagonal, are what? 0. You have it as what? Lower triangular matrix. Then we have the symmetric matrix. The symmetric matrix is a matrix where the transpose will be equal to the main matrix, that is matrix A. So you have a matrix whose transpose is the same as the original matrix. So let's say this matrix A is 5, 1, 9, 1, 8, 6, and 9, 6, 5. Now when you transpose means you take this row to become column. The rows become what? Column. That is 5, 1, 9. You have it to turn to column to be 5, 1, 9. You have the next row 1, 8, 6, 1, 8, 6 column, 9, 6, 5, 9, 6, 5. So in this case now we have that the original element, the original matrix is equal to the transposed matrix. So we have this kind of matrix to be called what? A symmetric matrix. We have the anti-symmetric matrix. The anti-symmetric matrix is a square matrix whose transpose is its negation. That is to say, we have the main element, the main matrix here is what? 0, 2 as the element as you see them. Now let's take the transpose of it. You know this 0, 2, minus 1. So we have it on the column 0, 2, minus 1. Minus 2, 0, minus 4. We have the minus 2, 0, minus 4. and then 110. Okay, one. Okay, this should be 4. 140, and then we have it to be what? 140. Now when you compare the main matrix to the transpose matrix, you observe something. You observe that this is a negation of this. That is to say, here is 0. You know 0 can be positive or negative, so it's still 0. Then this is positive 2, this is minus 2, that's the negation. This is minus 1, and then the negation is what? 1. Negation is like the opposite of negative is positive. Positive is also what? Negative. So minus 2 you have 2, 0 you still have 0, minus 4 you have 4, 1 you have minus 4, 1, 4 you have minus 4, and 0 is what? 0. So these are the various types of matrices. We have various types of matrices, as I've mentioned: the symmetric, the anti-symmetric matrix. So in my next video, I will show you how to solve some matrix problem within the addition, the subtraction, the multiplication, how to use it to simplify simultaneous equation. So if you have not subscribed to my channel, why not do that and subscribe for more on matrix. See you in my next class.